How's it going, everyone? Welcome. Elvier Gonzalez here, and let's take a look at this data fetching model as part of the additional tools that we have in React, additional to components, right? So in today's video, I'm going to, explore a bit of this. I will make a quick recap of how do I get here. What I'm gonna do is briefly mention is what are the alternatives that we have before React, all right? Or how can we now is fetch some content or for sending requests in the React context, okay? So before React and even the fetch API and the JSON, we have these things called XML HTTP requests, which allows now a client scripted, so for example, the browser, the JavaScript engines, and by exposing now an API to these programs, we can now send requests or do a data transfer from client to server. So this is what the XML HTTP request is all about, right? And that's interesting because this follows where it is. There you go. Because this follow is this living standard, okay? And here you can see how you can create now is your request. But this particular way of doing that is using the observer pattern, or in other words, you are going to create that XML as I look at this, right? So you either now create that object. Why is not? What about now? So you either create that object. Hello, Jesus. You either do that XML HTTP request. You either create that object, hold that object reference into a variables, and then you start to open the connection by saying XHR open, and here's when you say, hey, the first parameter will be the method you want to do this data transfer. Hey, do you want to get data or send data or update data or delete data, right? In my case, it's using to read data. The specific URL, which in my case I'm gonna use is the do me JSON like that, right? There you got is this, yes. So for example, like this, all right. I copy and paste this. They're gonna call this the users, right? And then you say third parameter is true. You're gonna see that later on. And then this is when you say, hey, I want to transform now as the request object. I'm not quite sure how to transform this or the particular method to transform that. Response types, getter and setter. I think it's this response type. What is the response type? Oh, the event summary. Okay, this is all the kind of event that you can listen to. Again, this is part of the observer pattern. All right. So anytime that there is an event, is this particular pattern here. I just want to look at this response type. Okay. So if I look at that, no, this is fetch later, but this is if I look at the response type, that's right. So here on the response type, right, I say, hey, how do you want to be this? Can be set to change the response type. The values are empty, array buffer, blob, document, JSON, and text. So in this case, I say, hey, transform this into a JSON. Okay, and then I do want to is attach now some function callback here, right? So when I listen to those or to that particular event, for example, like this, when you are on mm, 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 on load, all right, which is the method here. So on load, this is the function that I want you to assign to this, and you internally going to execute that. So in other words, is this function you're gonna call this is fetch succeeded. Okay, so this fetch succeeded, all right, it's going to say, all right, I'm going to receive, of course, now is an event. I'm assuming that, right? Referencing garbage collection, event handlers, and the second method. That's right. Progress event. So I'm gonna receive is this progress event, right? That is of the shape of the event, and it has additional properties like length computable, loaded, and total. Okay, so again, I just want to make these things pretty straightforward, just by copy here this and say, hey, I do want to check if the status is on the 200 range, and if it is, all right, I do have now is that's interesting that it's not using that. I do have now is the data there, but I want to have access through the response object. We can also attach some XHR on error, right? And define some function here as well to say it as on error, right? And well, we're gonna see, we want to show something here, right? So if you receive some status code or some network error, you're gonna throw this as it is. We can, since this is returning now an error, we can is print that out, that error on that happen. And then is when the actual request happen, when you call the send method. On which line? On which line? On which line? Line 8, it says line A, line A, line 8 is line 8 function fetch here. If I click here, let me check it. Line 8. Oh, you're right. You're damn right. There is a missing if. All right. XML is not defined. That's quite interesting. HTML HTTP request is not defined because I didn't use that. Is XML HTTP request. Okay. And did I miss something? I do think I missed something. I do think I missed something, but it's on here, right? So if I now call this, I get all of this, so that's great. Response type is in a JSON. Oh, you know what? Let me reload this. and then do this again. That's interesting. Function fetch succeed. Okay. What if I don't pass? If this is an anonymous function, it doesn't change that much. Yeah, that's interesting. It's like it doesn't work here. Oh, I must have some particular error because it's here on error. Okay. Okay, so I fixed that. That's interesting. Response type is as it is. Oh, because it's unload. Exactly. There you go. All right. Yeah, the name of the function. Okay. Is on error because it's an event, and then unload. All right. So now when I run this, it actually worked as expected. Okay. So even though the specs are not quite descriptive about this event or the event summary, but in any case, you need to call them as like on. Okay, no problem. But in any case, but here's how you do this before now having this fetch API. And because fetch say there are several resources that we need there are several resources that request piece of information, right? And the goal is to unify all of them, right? Because at a high level, this fairly fetch operation, which is where a request goes and a response comes out, okay? Since there are numerous APIs that fetch resources like the script, like the CSS cursor line, list style image, the navigator.sendBeacon, self.importScripts. So they want to lay out the infrastructure needed that are consistent across all of these different APIs that fetch some resource. Okay, so they simplify that, including the fetch API. All right. So in other words, when you are now fetching the image script, or when you are fetching an image or a script, or on the CSS the cursor on the line style image, or in the navigator.sendBeacon, or self-import script in JavaScript API, or even the fetch, all of them now are promise based. Okay, so the goal of this is to unify fetching across the web platforms and provide consistent handling of everything that involves, including URL schemes. That's interesting. Unify fetching across the web platform and provide consistent handling of everything that involves URL schemes, redirect, cross-origin semantics, CSP, what the freak stuff is CSP, content security policies, fetch metadata, service workers, mixed content, upgrade insecure requests, and referee. The referee policy. Interesting. This document describes how an author can set a refer policy for documents they create and the impact of such policy of the referee HTTP header for ongoing requests and navigation. So, all right, again, we're getting too loose into the details, but this is how now this infrastructure, or how the fetch API is describing how we're going to unify is fetching resource on the web. All right, or at least for this specific, so for an image, script, CSS cursors, self-import, and the fetch API. And yesterday I read about this to say, oh, so how does it work? All right. And on the preface actually is describing this, at least when you look at the fetch API here, that this method actually describe is what it's going to do behind the scenes in JavaScript. And it say this is going to create a promise and all of this kind of stuff. I won't dive deep into this, all right? Because the goal of today's video is to, well, look at now how you can fetch data or how you can send a network request in the React context. So because there is a huge, okay, there you go, this one, data fetch, okay, and a bit of example and a bit of history here. There you go. Right. Okay. Good. So, so here I am. Data fetching, tool of choice. You can learn about the basic of working with fetch in the fetch basic with primalist. But again, so exactly. So in this lesson, we're gonna see this, right? So in this lesson, we're gonna see how to send network requests in React context. And here is described as a tool of choice, right? Tool of choice. And that is, so yeah, there is a huge universe of tool out there to manage network requests for us. In this course, we're going to use Fetch to make requests. Fetch is part of the web platform, built right into the browser. If you're not familiar with, you can learn about the Fetch basic series. So let's use now the fetch API, which is the modern way for sending requests or for sending network requests in modern web development or in modern web apps. Okay, which is good. If you want to learn about it more, you can read about that. If you feel curious, you can take a look at the specs, right? There you go. All right. So because in the context of React, fetching data is one of the most important things. Okay. Tool of choice. So it is becoming increasingly popular in React community to use third-party libraries, tools like React Query or SW. Yeah, it is, or it has become quite important to use tools like React Query okay, like React query or SWR, stale while revalidate, to help with network requests, to help with network requests. Okay, so we got this, whether it's this one, exactly. SWR, stale while revalidate, or React query. Like this. But again, in our case, we're using is this exactly React query, use query. I think it is. Oh, to compare across examples. npm run and npm run def. Oh, okay. Whether it's React, Vue, Angular, Solid, and it is fetching the data. Okay. Exactly. So on that particular component, you just use that. Oh, you first create is a client. That client is gonna be injected that. The question is that what this object is creating. That's a good question. You know, what this object is creating, and then your examples here. So when this component is mounted, it's going to call this custom hook. Why do I know this is a custom hook? Well, by the use prefix, by the use prefix here. And here you say, I'm gonna give you now an object that this is the query key, and this is the query function, right? And it's pending, is returning loading. So this now is gonna give you several of them, several of these custom hooks. So it's pending, returning, and loading. Is error, returning an error has occurred, error message. So once you show this loading, all right, and when that state change, because it will be internally handled, not for you, but by the custom hook use query, then once that change, that internal state change, is going to evaluate this, is going to go through this statement, and this another one, and because both of them are not true, then it's going to now render this one, which contain is the actual data that you can see as it is, right? If you reload this, you say loading, and then show you this, right? That's interesting. This is how you can use now on React. The other is how you can use that on Vue, right? Which actually is pretty similar. I'm assuming that they are need to mount that. That's right, because this is now part of the application. Unlike React, that you do that is as per tag, right? Here you do this is as like a middleware. Again, two different approaches. They want to achieve the same result. And here you define is now in your setup. Here is this. So this setup component is say I'm gonna kick off when this component, before this component is get mounted, all right, and I'm going to give you this, right? And again, this use query is again some hidden methods that is using now is reactive values, all right, that are transparent to ourselves, and then it's going to now render this in a Angular-like style, right? I don't want to dive too much into this, but I just want to mention is what you can do here with it. This is it. Again, Svelte follow the same pattern as React by now creating that and then inject that, as you can see here. And it's also mixing is a script tag with the markdown. All right, and this is I'm assuming that this is when you call this simple, exactly simple does vel, and this is what it's gonna do when this component is mounted, right? It's going to now evaluate this. But in my case, I ignore how this is being processed. You know, I don't know how these things are processed. So, but in any case, and again, as you can see, it contains now its own templated language. Why is that? Well, because it turns out that this is now this compiles this code, in my understanding. So in any case, there you got it, right? Oh, I didn't add this. Okay, there you got it, right? React query, there you got it. All right, let me put it this here. And there's some prerequisites to do so, right? So prerequisites. Okay, I need to put it inside of this. Okay, so the prerequisite there you go. Prerequisites. Well, that you need to know exactly. There's a fair amount of knowledge that we are assuming. Here, there is a fair amount of knowledge that we assume. That we assume, right? Like, well, synchronous and asynchronous code. Synchronous and asynchronous code. HTTP request or promise. HTTP methods. Okay, this is part of the anatomy here, and the fetch basics. So let's get into each one of them, shall we? All right. Let's get into each one of them. Synchronous and asynchronous code. I already know. Well, this is just to read about that in developer. The other is a promise. So get yourself familiar with what a promise is. And a promise represents an operation that hasn't completed. In other words, it's an eventual value. In other words, it's concurrency that you're dealing with. All right. Developer, prepare yourself for a pivotal moment in history in the web development. How old is this article? Yeah, how old is this article? 2013. Holy moly. Okay. So as you can see here, browser middle of this. At this point, you fall into one of these categories. People are cheering out around you, but you're not sure what is the fuss is about. Maybe you are not even sure what a promise is. You have shrugged, but the weight of glitter paper is weighing down on your shoulder. If so, don't worry about it. It took me age to work out why I should care about this stuff. You probably want to begin at the beginning. You punch the air about the right time. You just use this promise things before it bothers you at all implementation and have a slightly different API. What's the API? The official JavaScript version. You probably want to beginning with the terminology. And it is. Yeah, let's get into this. Let's get into this. Synchronous and asynchronous code is something that I'm quite familiar with. All right. So synchronous code is when we now things that the program expect to evaluate the code one line after the another. All right. And also we can have this long running test that can block that. The trouble with long running tests, all right, is that they can block the main thread. Because at the end of the day, JavaScript is a single thread program. Just to make a quick recap, a program is when a binary portable executable code that lives on disk is mounted into memory and executed by the CPU. This creates a process. And this process contains several so this process has or this process contains several programs inside of this. It is safe to call that programs. If you take a look at this on YouTube of ByGoGo, of process and thread. Fair use.
What's the difference between process and thread? This is a common interview question. Let's take a look. To better answer this question, let's first understand what a program is.
Exactly. So a program is an executable file that lives on disk. Okay, that's a program. So I'm just making this quick recap of this. So a program is this portable executable binary file that lives on disk, and when that is mounted into memory and executed by the CPU, it creates now a process.
A program is an executable file. It contains the code or a set of processing instructions that is stored as a file on disk. When the code in the program is loaded into memory and executed by the processor, it becomes a process. Program instructions that is stored as a file on disk. When a program is an executable file. It contains the code or a set of processing instructions that is stored as a file on disk. When the code in the program is loaded into memory and executed by the processor, it becomes a process. An active process also includes the resources the program needs to run.
Exactly. So an active process, it also includes additional resource that it needs to run.
These resources are managed by the operating system.
And these resources are managed by the operating system.
Some example
of these resources that are managed by the OS are register. It's because they are resource. Is there register, program counter, and the stack.
Those are processor registers, program counters, stack pointers, memory pages assigned to the process for its heap and stack, etc. There's memory pages assigned to
the process for its heap and stack. What does it mean this? Okay, so the heap is where the process assigns memory for objects created, and the stack is what it does to keep track of where in the code it is executing, like which line of the code is currently at, right? But all of these are resources that are assigned by the OS, which now are provided to the process. And the process now manages several resources. Okay?
An active process also includes
An active process includes resources. It makes sense. Okay.
resources the program needs to run. These resources are managed by the operating system. Some examples are processor registers, program counters, stack pointers, memory pages assigned to the process for its heap and stack, etc. There is an important property of a process that is worth mentioning. Each process has its own memory address.
Exactly, and this is now describing is the property of the process. So each process now live in its own memory address space, which means that one misbehaving process won't compromise other process because they are now isolated into their own. So the difference is with the thread is now, since threads is this unit of execution that it lives inside of a process, and at least you must have one, that you can have multiple threads that is going to share now process resource, and that is the heap or the memory. All right. So the problem is that one misbehaving threads will compromise the entire process. So that's quite interesting.
Space. One process cannot corrupt the memory space of another process. This means that when one process malfunctions, other processes keep running. Chrome is famous for taking advantage of this process isolation by running each tab in its own process. When one tab misbehaves due to a bug or a malicious attack, other tabs are unaffected. Now, what is a thread? A thread is the unit of execution within a process. A process has at least one thread. It is called the main thread. It is not uncommon for a process to have many threads. Each thread has its own stack. Earlier we mentioned registers, program counters, and stack pointers as being part of a process. It is more accurate to
Exactly. I mentioned that these resources are part of the process, but it's more accurate to say that those resources that the process use like this, because at the end of the day, an active program also include is process or resource. An active process includes also resource, right? So those resources now are part of the threads. So the stack, the register, and the program counter.
Earlier we mentioned registers, program counters, and stack pointers as being part of a process. It is more accurate to say that those things belong to a thread. Threads within a process share a memory address.
Exactly. And thread within a process shares a memory address space. Remember, this process lives inside of its own isolated memory space.
It is possible to communicate between threads using that shared memory space. However, one misbehaving thread could bring down the entire process. How does the operating
system run a thread or a process?
System run a thread or process on the CPU. This is handled by context switch.
And how a process or thread is being executed by the OS, and this is managed by the context switching. Or you also have another alternative like fibers, or or you have other alternative like fibers when the
switching. During a context switch, one process is switched out of the CPU so another process can run.
So one process, during the context switching, one process is switched out of the CPU so another process can get in.
The operating system stores the states of the current running process, so the process can be restored and resume execution at a later point. It then restores the previously saved states of a different process and resumes execution for that process. Context switching is expensive. It involves saving and loading of registers.
And this is one of the key things of all of these programs at the end of the day. So saving and saving.
Context switching is expensive.
Saving.
It involves saving and loading of registers.
Saving and loading the register, or saving and loading a state of that.
Switching out memory pages, and updating various kernel data structures. Switching execution between threads also requires context switching.
Switching execution between thread is also required context switching.
It is generally faster to switch context between threads.
Okay. So whether it's process context or thread context or context switching.
Than between processes. There are fewer states to track, and more importantly, since threads share the same memory address space, there is no need to switch out virtual memory pages, which is one of the more expensive operations during a context switch. Context switching is so costly, there are other mechanisms to try to minimize it. Some examples are fibers and coroutines.
Exactly.
These mechanisms trace complexity for even lower context switching cost.
These mechanisms trade complexity for even lower context switching costs.
In general, they are cooperatively scheduled. That is, they must yield control for others to run. In other words, the application itself handles task scheduling. It is the responsibility of the application to make sure a long-running task is broken up by yielding periodically.
So in other words, now instead of keep tracking of all of those states by the OS, is now at the application level that periodically yield this task. By periodically yield this task, and it is that at the application level. That's what it is trade-off complexities versus lowering context switching.
This concludes our discussion of.
So why am I mentioning this? You might wonder, right? Well, because when I talk about synchronous and asynchronous code and how the things actually works, particularly in the case of JavaScript, so JavaScript behaves right now, the engine, the observable behavior is more like a compiler when it analyzes the code rather than an interpreted language. So this synchronous and asynchronous code, I will quote here the You Don't Know JS series, because it actually describes way much more how these things work. Let me put it here on the scope and closures, okay? Because here you can have now a more understanding of this. I will definitely quote that. So in order to understand this, you need to know what a scope and closures are. Okay, from the you don't know JS Jet series book, and then you got it. Okay, and then you got now promise. So a promise, I won't dive too much into this. So Domenica De Nicola, Twitter. Interesting. Dominic De Nicola, Tokyo, Japan. I wrote about my brush with Cloud Go psychosis and how it is made maintaining GSDOM more fun than it probably should be. The wrong work done beautifully. Working on GSDOM was a leisure activity. I get home from my day job working on web standards and then 35 million log Chrome web browser at Google. And then I unwind by implementing some web standard and fixing some bug reports in my scrappy 1 million LOC GSDOM code base. 1 million LOC GS code base, bro. Holy hell. I still have a soft spot in my heart for GSDOM, which maintained an inexplicably popularity at 48 million weekly download compared to React 80 millions. When I asked to participate in AI coding productivity study, I leaped at the chance of fixed backlog of GS issue, and recently a new contributor has appeared and throw themselves into fixing our selectors and CSS subsystem. I'm doing my best to stay responsive to get their diligent work released to the world, but if pressed, I will say the project is in maintenance mode. After we moved to Japan, my wife and I tried snowboarding. She took it, but I did not. What can I say? Okay, a gear heavy, high learning curve, single season, somewhat dangerous, adverse weather, and you get the idea. So, well, there was one GSDOM bug that got filed in 2019 and immediately made me embarrassing about how I got in such a fundamental thing wrong. I always thought myself I have fixed it in next weekend, keeping it on my task list for far too many years before facing the reality that I wasn't going to prioritize it. But maybe with the power of Claude, now has the time. The next 3 weeks flew by in a blur. I definitely caught the Cloud Go psychosis. Cloud Go psychosis. If you're telling a friend that you can now instantly create any app, they probably say, cool, now we need to think of an idea. In any case. So why am I reading about this? You might wonder. Well, it's because Dominic de Nicola actually is a developer here. Which now is part of the promise here to describe that. I found myself reopening my laptop during any spare interval before we went out dinner and I spent 10 minutes writing a big prompt so I could get the thrill and seeing what Claude produced while I was gone. I daydreamed about setting one of those Cloud Go from my phone setup people are advertising on X. This time around, the intensity of the work pulled me deeper into agentic coding ecosystem. I started using Git worktree so I could factor out smaller PR from the main work and land them independently. I added an agent once and I have enough experience to know what it will say. I tried Codex CLI, verified the rumors that it can work autonomously and churns out a ton of code in a given test suite, as long as you're willing to babysit it through a sheet of ton of pointless permission escalation. I briefly experimented with Codex Web before deciding that it was too lazy for my needs. After we completed the first pass of rewriting 5 days, I realized that I wanted to go further, so I squashed those 43 commits into one and starting another branch. 77 commits and 8 days later, that was ready. God damn it, bro. Replace the resource loader API. Holy moly. I let GitHub Copilot and GPT 5.2 codecs have a crank at reviewing if they found some good issues. I finally merged into the main GS done. And part of me is very happy with the end result. I think the new API and the code behind it is beautiful. I am proud of how I engage with Claude and other agents. We close high difficult open issues, one dating back to 2016. I engage with the author of Unidici, the library underlying node fetching infrastructure, and report several bugs. But wait, should I? Cloud cannot magically make GSDOM into a viable project. On the other hand, fixing a bug dating back to 2016 is gratifying. I agree with the general sentiment of Opus 5.4.5 Codex 5.2 generation represent a step change that also back in the July is this. I am not aiming for a lesson here, more on observation, unlike Shen, whose blog is full of great takes of how to add value to software engineering, or I'm retired. Retirement, bro. Retirement. I reach a point with my Japanese flashcard project where I need to do more user testing and develop. So anyway, but in any case, it's him, right? And that was quite. So it was a couple days. It was 2 days ago, by the way. All right. Okay. Okay. Good. Good, my friend. But I'm looking is at this. You know, I'm looking is at least the terminology here. Events aren't always the best way. Yep. And this is the most basic promise and a bit of listeners except for all. And promise terminology here. So this is the promise here terminology: fulfilled, rejected, pending, and settled. And the spec also used the term tenable to describe the object that is a promise like which you can change. There are several of them back then, but now we can actually use that. Promise arrived in JavaScript, compatibility with other libraries. Complex async code made easier, right? Promisifying XML HTTP requests. That's interesting. Okay, you're gonna so what you're gonna do is that get URL, and when that is done, you're going to throw that result .request.response here. Otherwise, the error here, and handle errors, handle network errors. This is to promisify this. And now let's use it. You say, hey, get story.json, and this is the function that you're going to on the response and on the error here. Okay, queuing asynchronous actions. All right, and error handling, and it's describing is pretty much what this thing is all about, right? So but in any case, the other is the async and await. This is a way of how you can make this code much more straightforward. HTTP methods. All right. The question is, can we send body to a get HTTP method? Technically, you can send a body with an HTTP request, but it's disencouraged. But the server is under no obligation to process that body. and the test API. So fetching on event. All right. So here we are. So I just want to now write it this as it is. This is how you can write this one. And loading success and error status. So loading this error and success and error status, it's a when submitting network requests, okay, we want to update the UI to indicate 3 different status: loading, success, and errors. In the video below, I'll show you how I implement this status and update the UI accordingly, but I encourage you to give it a shot yourself. Using the playground above, feel free to structure things however you wish, updating the UI whichever you may feel makes the most sense of it. So what we can do is, hey, I can now abstract this logic into a particularly custom hook. All right. Which I'm going to kick off after the event is mounted. But in this case, I'm just calling it as it is because I'm doing it as a post. So what I can do is wrap this code, this async code, into a try and catch. All right. And if for some reason you find now some errors, all right, well, please let me know about it, right? We can say it's either or console.warm and say, hey, there was an error, and show the error in itself, all right? So when you're trying to reload this, all right, and well, now keep track of that state of the piece of information. So I do want to say, hey, reuse uses state here, and now make these things. So define is here I'm using is just plain JavaScript. I can define is it'll loading success and error, right? This is the 4 possible state that this is the 4 possible values that this state can be. And I'm gonna call it I'm gonna call it here that's a good question. How do I gonna call it here? Yeah, how do I call it here? Network request, how do I call it here? Email message. Or status. Yeah, but what status? Network status, and set network status. That's more descriptive, right? Or you can call this as request status. Yeah, network status, because that's what we want to represent here. Okay, so when this is triggered, I can say, hey, show this loading first, right? Network, set the network status loading, all right? And once that is done, I do want to update this to say on success. If there is an error, I want to trigger is the state update to say now error. And And that's pretty much, this is it. Right? This is it. This is it. This is it. Right? So if I do this and say I'm gonna send now an email, and I'm gonna leave these validations to be handled by the browser input. I'm gonna say any message. I'm gonna now trigger that. So the submit is not triggering anything here. That's great. So what I can say here is, well, I do want to show is submit. All right. I do want to show is submit value, but only when this is state, you can say network status, but only when the network status is different from loading. Okay. If the network status is different from loading, I want to show is submit as it is. The submit value, right? So is this one on the submit value. So otherwise, I want to show now is submitting, right? Perhaps it doesn't have the great with this UI, but at least it will work as expected, right? Submitting. I would like to disable also that. All right. I would like to also disable that. So I would like to say, hey, disable here. So disable only when the loading status is equal to loading. All right. So evaluate this into a evaluating that's this expression, and give me now a Boolean value. So if I say doing this, and then I submit, now it's unloading, and as you can see, it's showing me that. Good. Now after that, I want to is clean up that response. So well, what I can do is, if now that is a success, right? I want to now is clean up the state of the email and of the message in this case, right? So after that, I submit. If that is succeed, it's a success. This is it. I do also want to show now something, right? Some message here that say, hey. So after that, I want to render is this. If the network status is equal to success, all right. I do want to show is this message send, right? Message send. Yeah, only this, you know. So I want to evaluate this. So evaluate this statement here, all right? And whatever value you get from that, make it now or coerce that into a Boolean here. Okay, so if I send a message successfully, it's gonna show now message sent successfully. I can now try to remove that and draw that right below as it is, right? I can wrap this into a div here. Okay, we're trying to put it here. I maybe use a particular class called row here. So it doesn't center that element here, but it doesn't matter. Yeah, you're gonna leave that. I don't care about the style right now. I just only care about to handle that state properly. So if I reload this, right, this is what it is. So if I now look at this example.
So the first thing I'm going to do is I'm going to create a new status state variable. And the idea is that this variable is going to tell us how things are going at any moment in time for every snapshot that we render of this component. And it starts life as idle, which is the status where they're entering their data in the form, they haven't submitted it yet. Once they submit it, it's going to flip to loading. And then once the server responds, it'll either be success or it'll be error. These are the 4 states that I find myself using over and over and over again because they tackle pretty much any network request in terms of the things that can happen. And when they submit the form, I'm going to set the status to loading, and I'm doing this right away, like even before I've started the network request. Then the network request will take some amount of time to happen, and then afterwards I can choose whether it's a success or an error. But how do I tell the difference? I think a lot of developers expect that if the request fails, that we'll throw an exception. So maybe I can wrap this whole thing in a try catch, and that way when it throws the exception, I can catch it and do my status updates in here. But it actually doesn't work that way. Assuming that it is the server responding with an unhappy status code, like maybe a 404 or a 500, that doesn't actually produce an exception on the front end. It means that the response will have a different status, and it means that the JSON will be different, but everything will continue running smoothly. And so one option is I could check response.status, right? This will be a number. It should be 200 if everything went well, 400 and something if it was a client error, like something that I submitted that was wrong, 500 and something if it was a server error, so I submitted things right, but something's happening on the server, maybe it's on fire. But there's also 300 series statuses where it's a redirection, where it's still valid. And then there's the case where maybe the backend hasn't used status codes correctly. And so in my experience, this is like a good idea in theory, but in practice, I prefer to check the response itself, right? The data that I receive from the server. And so if I submit this form, we can get a preview of what that data looks like. And I see that I have an OK property, which is set to true. This is how I'm going to tell if the response is valid or not. So I'm going to say if json.ok, and in that case, I'm going to set the status to success. Otherwise, if it's anything else, I'll set the status to error. And so with these 3 calls done, we now have a status variable that accurately reflects where we are with this submission, and now we can start using it in our UI. And I'm going to start by adding the disabled attribute to inputs if the status is equal to loading. And I'm going to do the same thing for the text area, and even for the button. Looks like we've gotten stuck in the loading state thanks to a hot reloader update. But if I refresh the page and try this again, we see that the moment I submit the form, everything grays out until the response completes and then it becomes valid again. I like to disable inputs on submit because it stops the user from accidentally double-clicking the button and making multiple submissions. It also means they can't edit their field while we're in the process of submitting it because any edits they make wouldn't be received by the backend. But I don't think it's enough on its own, because it is a bit confusing. Like, what does it mean that they've been disabled? So I'm also going to change the text in the button. And I'm going to say if the status is equal to loading, then I'm going to make the text submitting with a little ellipsis. Otherwise, it'll stay as submit. And so now when I submit the form, we see the text changes. We could also put a spinner in this case. That would also be a good idea, as long as we make sure that the text is still there for people using screen readers. But overall, I'm happy with this as a loading state. What about the success state? What do we do if the request resolves successfully? And really, it depends on what we want the user experience to be. There's several valid options. One could be that we return something else entirely. So if the status is equal to success, then we don't return a form that they've already filled in. We return a paragraph with the text message sent. And so now, if I try to fill in this form and submit it, we get our loading state, and then at the end, we see message sent. Obviously, we would want the designer to help with this, like it does feel a little bit too minimal, but this is the fundamental idea with the logic. We check and see if it was successful, and then we render something else. But what if we want to let the user send multiple messages? Well, in that case, I'm going to take this paragraph, and I'm not going to return it as a separate thing. I'm going to include it at the bottom of the form if the status is success. That way, they can submit the form, see the loading state, see that it was successful, but continue to send additional messages. And I do see now, it would be nice if the message erased. I think it makes sense to keep the email address because presumably this is the user telling the website administrator how to contact them, and that doesn't change. But if I want to send multiple messages, it would be nice if the message box emptied itself. And so I'm going to update when we set the status to success to also set the message to an empty string. That way, I submit the form, and once it's successful, I see that the box has been cleared for me to send another message. Now, in terms of error states, to make it easier to test, my endpoint with this test API I've created supports passing a query parameter called simulated error. And if I set that to true, and I submit the form, we're going to wind up in an error state. And if I pop open the DevTools and go over to the Network tab, and submit it again, we see the request start and the request throw a 500 error. And if I look at the response, I see that I
simulated error true, simulated error, but I don't think it actually do that. It's going to show this message sends on the success, which is here is simulated error, simulated error true, simulated error true. That's interesting.
I still get a JSON object that has this error text. I wanted to make sure to include the simulated error information so you can always tell the difference between like it doing what it's supposed to and returning a simulated error versus it having a real error because something is wrong. So you can always check the response. You could also console.log the JSON that we get back, which actually I am doing, so I could have showed it to you there. We get this data back so we can tell if the error is legitimate or not. And so we are setting the status to error, but we're not using that status anywhere. And again, this is something that is really going to vary depending on the application. I think in this case, I'm going to duplicate this paragraph, but for the error status, and change the text to something went wrong. We could get really granular with errors and include the error message from the server and highlight the field responsible for the error. But I feel like nowadays, because we have such rich client-side validation, like if I try to submit this form with a required field that's been left blank, the browser will tell me about that. And if I try to submit an invalid email, the browser tells me about that as well. So as long as I use the required attribute and make sure to set my types correctly, and use all the other validation things we have access to, like min length, we don't have to implement a bunch of custom logic. We can rely on the browser itself. Now, we generally do want to duplicate that logic on the back end because it's easy for users to circumvent this logic. They can change the HTML. But if someone is trying to hack our system, I don't feel like they deserve really nice and proper error messages. So like that's no problem for me. But yes, as I say, right, the actual UI we render will vary depending on our application and what we want the user experience to be, but the strategy of having a status that always reflects the current state of the current snapshot, this strategy is solid.
And then the fetching on mount, fetching on event and fetching on mount. This is a surprisingly thorny problem, and it might seem like a slight difference fetching on mount instead of fetching on event, but it opens a whole can of worms. It opens a whole can of worms, bro. Okay. First, the ergonomics are tricky. In order to fetch on mount, you generally use the use effect hook. But there's some gotcha around using async and awaiting an effect covering up in the incoming lesson. Also, if we want to solve this problem in a robust production-ready way, there are all sort of concerns we need to worry about including. But this is the two scenarios of how for fetching data in React context, whether it's on event or when the component mounts. Catching the response so that it can be reused by multiple components across the app. Exactly. It also and also, if you want to solve this problem in a robust production ready way, there are all sort of concerns we need to worry about, including catching the response so that it can be reused by multiple components across the app, revalidating the data so that it never becomes too stale. This is a rabbit hole, and we could get lost it for days. As a result, it becomes in the community to use a tool for help with this stuff. The React docs, for example, suggest using a package like React Query or SWR. In fact, of this course, I use SWR to solve all of these hard problems for me. But again, this is a specific to fetching on mount. And here's an MVP implementation, and feel free to poke it at production and we'll get over with it. So if I switch to this, oh, that's pretty fucked up, bro. This use WSRC, man. And throwing an object here. But I do want to have access to this, particularly the GitHub here. Because now this exposed this stuff. Mm. Mm-hmm. Mm-hmm. It's using now this catch strategy, which is still well revalidate here. But again, they stand on they stand on that GitHub Husky example immutable. Infinite, a mutation, and a script. Bump next version. And source, and is here on the subscription, on the mutation, and the infinite index, and the immutable, and some internals. Mm-hmm. So look at this. They're using now another custom hook, a ref, a React ref, exactly React hooks, another React hook, and then now this user state with depth, which is at the end of the day, user state with depth, and then the start transition. This is where the actual magic happened here. You have now the current state, the trigger, and they use callback, use isomorphic layout effect, and there you got it. Use WR mutation with middleware. It is pretty fucked up because when I change this, something goes wrong. But if I reload this, it says something goes wrong. That's interesting. What if I go here exactly? I switch tab, and then I go back. Still will revalidate. That is mind bending, bro. Again, to cover these specific edge cases. Use a state on this state that live under this state here. And this is actually where it's going to roam. Okay, to remember this piece of information. Unmounted ref, use a state, use ref, and here you are now holding is a piece of information here. If I state properly, data error or is validated is accessed by the render function, we mark the property as a dependency. So if it is updating again in the future, we trigger a render. This is also known as dependency tracking. And updating the state triggers a re-rendering if necessary. Set the state. And use isomorphic layout effect. All right, okay. So let's continue to read about this. Particularly this.
So I recognize there's a lot going on here, but fear not, we're going to walk through how all of this works. The first thing on line 2 is we are importing this custom hook called useSWR from the SWR library. And I'm so excited about custom hooks because they make things like this possible. It's not only useful for ourselves, right? If we have some bit of logic that we've written, we can wrap it up in a custom hook and then reuse it. We can also grab third-party custom hooks, right? Custom hooks that other people have written. And in this case, I expect the team has spent hundreds, if not thousands of hours building and optimizing and battle testing this hook. And so it's really cool that we get to import it and use it in our code like this. And the way it works is that we call the use SWR hook and we give it two things. The first thing is a key. This is meant to be some sort of unique identifier for the particular API route that we want to make a request to. Unless you're using GraphQL or doing something kind of funky, you want this to be the endpoint itself, right? The location that you want to make the network request to. The second thing we give it is a fetcher function, and here we hit probably the biggest misconception around libraries like this. I think people think that if you use a tool like SWR or React Query, that it totally abstracts over the data fetching process and it manages all of this stuff for you. When in fact, like as you can see, we're doing a lot of the same work we were doing in the previous lesson when we were making a request without any sort of library. Tools like SWR are meant to be agnostic when it comes to the actual process of fetching data over a network. So you can use Fetch or Axios or any tool that you like for actually making the request. The difference is that we're packaging that stuff up in a function and we're giving this function to the library. And so use SWR is going to decide when exactly to call this function and what to do with the returned value. Now in this case, we're making a request to the endpoint, getting it as JSON and returning it. And so whatever I return from this function, in this case, this JSON object, will become the data variable inside this object that we get back from calling this hook. And we can see in the console we have an example. We have OK set to true, and we have temperature set to 19. By the way, I should say, I didn't really build like an entire backend weather API that knows real temperatures. So this is a random number. It's meant to be a number that is realistic in terms of temperatures here on Earth in Celsius. But yeah, just know that we're not literally fetching your local temperature here. Once we get that data, we're getting it as the data variable from inside use SWR, and then we're using it to control the rendered output like this. And so if we think through the entire flow, this component mounts, we call the use SWR hook with a unique key and a fetcher function. SWR is then going to call this function, and it's going to provide the key as the first parameter. Now this might look a little bit silly, because this variable and this variable are the same. They're both this string right over here. And so I could just as easily not have a parameter and use this kind of all caps hard-coded endpoint within here. We still get the exact same result. The reason that it's generally preferable to do it this way is that it keeps this function being really generic. It isn't tied to this specific endpoint. And as a result, I can keep this in like a helper file and import it whenever I want to make a new request all over the application for all sorts of different endpoints. Inside this function, I make a request to the specified endpoint, I get it as JSON, and I return it, which populates this data variable with whatever was returned from that endpoint, and then I can use it in my JSX. Now I know that this seems like an awful lot of trouble. Like, it may not be clear what the benefits are to using a tool like this. And there's quite a few, but to talk about one, in fact, we're going to talk about the one that it is named after. SWR stands for Stale While Revalidate, and it refers to an HTTP caching strategy. The idea is that after a certain amount of time, or after certain things happen, this data might grow.
Exactly. After an X amount of time or after certain things happen, this data might grow stale. Or this data might grow stale. Yeah.
Is that after a certain amount of time or after certain things happen, this data might grow stale, right? The page loads, I see the temperature is 28 degrees, but if I spend several hours on this page, well, this probably isn't the right temperature anymore. And let's suppose I change tabs and I'm doing something over here, I'm gone for a while. When I come back to this tab, it's probably a good idea to fetch new data. And so if we wait a minute, we see that it does indeed update this value. And again, these are randomly generated numbers from the API, which is why we see it changing. But it's the act of switching tabs and coming back that triggered that revalidation. Now you'll notice we don't see a loading spinner or anything else like that while it's fetching new data, because it chooses to show the stale data. That's why stale while revalidate, right? We're revalidating the data, but while we're doing that, we're keeping the stale data so that the UI always shows something. This is exactly the sort of problem that gets really annoying if you try to solve it by yourself in terms of when should I do this, right? What are the heuristics I should use to control that? And granted, the library does make a lot of this configurable, so you can choose exactly when you do and don't want this to happen, but it's just really nice having a library that manages all of this complexity for us.
Still will revalidate here. It's an HTTP catching strategy, bro. Still while revalidating for changing tab. Does support stale while revalidate like behavior for tab change. Here's the main approach. Window focus refetching. You say on data, refetch on window focus. However, note that refetch on window focus is actually a React query feature, not native Apollo client. For Apollo, you need to implement this manually. A catch and network fetch policy, built-in SWSR-like behavior. This is Apollo's closest equivalent to stale while revalidate. This return catch data immediately while fetching fresh data in the background, exactly like SWSR. Manual implementation for tab focus. You have to create your own hook. Let's say handle focus, refetch from use query, and we do that event listener when you focus. When there is a global event called focus, all right, I want you to now deal with this. Consider React query. If stay while revalidate with automatic tab refetching is a priority, React query times stack query has this built-in with refetch on window focus, and it is easy to configure for this use case. With approach interesting you most, I can provide more specific examples here. Okay. Again, this is to cover specific use cases here. Very specific use cases here. Now it's throwing an error, and this is how you're going to deal with this validating here. An early error is loading, is error, and then you're gonna do is this one. And the others are a couple exercises here. Okay. That's very interesting. I'll leave that as it is. So that'll be all for this video. Take care. Bye bye.